You ever look at a number and just wonder, is there something more to it? What if I told you that a totally ordinary number, like how many days you've been alive, could be a secret doorway to a whole hidden mathematical universe? Well, today, we're going to pull on that exact thread and see just how deep the rabbit hole goes. And it all kicks off with this, a tweet from a math blogger, just casually celebrating being 24,285 days old. You might think, okay, random number, right? But nope, that specific number is a key. It's the clue that starts us on this incredible journey. And that's the big question, isn't it? That number, 24,285, is what's called a Catalan number. So, what on earth are Catalan numbers? And why are they so important that someone would celebrate their birthday with one? All right, first things first, let's dig into that curious birthday number. We're going to unpack the sequence it belongs to, and you'll start to see why it's such a big deal in the world of math. Okay, here they are in all their glory, the Catalan numbers. The sequence officially starts with what we call C0, which is 1. And then it goes 1, 2, 5, 14, 42, and on and on. Now, fundamentally, what they do is provide the answer to a whole bunch of different counting problems that seem unrelated at first, but all share this common pattern of, well, balanced growth and return. So a list of numbers is cool and all, but what do they actually count? What are these problems they solve? This is where the magic really happens. Let's look at one of the most famous, most visual examples. I want you to picture this. You're drawing a mountain range. You only get to use two kinds of strokes, an upstroke and a downstroke. They have to be the same length. But here's the crucial rule. Your path, your mountain range, can never, ever dip below the horizon you started from. In math, these are called dike paths. Okay, let's start super simple. If you have just one pair of strokes, one up and one down, how many ways can you draw a mountain without going below the line? Well, there's only one way. You go up, then you go down. That's it. One path. And what was the first Catalan number after the starting one? 1. See where this is going? Now let's build on that. What if you have two pairs of up and down strokes? Well, it turns out you can create exactly two valid mountain ranges. You can go up, down, like two little hills. Or you can go up, down, like one big mountain. Two paths. And guess what C2 is? It's 2. The pattern is holding up. And here's where it all clicks. When you have 3 pairs of strokes, it turns out there are exactly 5 different ways you can arrange them to draw these mountain ranges without ever dipping below that starting horizon. And the next Catalan number is, you guessed it, 5. This sequence is literally counting these paths. It's amazing. But believe it or not, the story doesn't stop there. Catalan numbers are really just one member of a whole family of related number sequences. Each one has its own little quirks and its own cool applications. So let's meet some of the relatives. So first up, meet the fine numbers. You can think of them as the Catalan numbers' slightly pickier cousin. They also count those mountain ranges, those diked paths, but they have one extra rule. You're not allowed to have any hills. That is, a little peak that goes up one step and immediately down one step, right at the starting level. So here's how to think about it. Catalan numbers count all the possible mountain ranges you can make. Finch numbers are more exclusive. They only count the ones that don't have those simple little one-step peaks right at the beginning. It's the same basic idea, just with a tighter rule. All right, time to meet another relative, the Motzkin numbers. Now these guys count something that looks totally different, but is just as visual. They count the number of ways you can pick some points on a circle and draw lines or chords between them so that none of the lines cross each other. And get this, these Motzkin numbers pop up everywhere. Seriously, they're used in all sorts of fields, from counting paths on a grid to figuring out the possible ways RNA molecules can fold up. They're even used in chemistry and something called knot theory. It just shows you how these abstract ideas can have really far-reaching real-world connections. So we've explored the numbers, we've met the family. Now let's meet the man whose name is on the marquee. Because behind every great mathematical idea, there's a human story. And this story belongs to a 19th century mathematician named Eugene Catalan. Eugene Catalan was a Belgian mathematician, born way back in 1814, and he made some huge contributions to number theory.
He was so brilliant, in fact, that he even made a dent in one of Hilbert's problems, which was this legendary list of 23 unsolved puzzles that basically set the entire agenda for math in the 20th century. So, yeah, he was a pretty big deal.
But Catalan's name isn't just attached to that famous sequence of numbers. He also has this number named after him, the Catalan constant. And this number, well, this number has a pretty deep mystery at its core.
And here's the wild thing about this constant. We have calculated it to over 600 billion decimal places. And yet, we still don't know for sure if it's an irrational number. You know, one of those numbers that can't be written as a simple fraction. It's such a basic, fundamental question, and it's still stumping mathematicians today.
Okay, so let's take a breath and look back. Where has this whole journey taken us? We started with a single birthday number, and we've ended up deep inside this hidden universe of mathematical connections. It's time to tie it all together.
I mean, think about it. We kicked this whole thing off with a number from a tweet. That simple number led us to the Catalan sequence and this cool visual idea of counting mountain ranges. From there, we met its relatives, the Fine and Motzkin numbers. And then we found the human story behind it all, with Eugene Catalan and his still mysterious constant.
And that, right there, is the big idea. A single number, plucked from the everyday act of counting your life in days, can be the one thread that, when you pull it, unravels this whole beautiful, complex tapestry of interconnected patterns. It's just incredible.
So I'll leave you with this final thought. Our world is just overflowing with numbers and patterns, and most of them just fly right by us. So the next time you see a number that seems kind of random, maybe just pause for a second and ask yourself, what hidden mathematical patterns are hiding in your life?